Welcome back. So in this video we're going to specifically look at another experiment, and this one is to determine the level of dissolved and suspended solids in water. And I'll go through an exam question in this video also. As part of water treatment, an experiment can also come up, and the experiment is basically to determine the total amount of suspended solids present in a sample of water, the total amount of dissolved solids present in a sample of water, and to find the pH of the water. So to find the total amount of suspended solids in water, you would use filtration. To find the total amount of dissolved solids present, you will use evaporation. And to find the pH of a sample, you will usually use a pH meter. So let's look at each part now individually. So to find the total amount of suspended solids in a sample of water by filtration, what you need to do is you need to take a specific volume of your water sample and you set it up for filtration, and there's a little diagram here for you showing you the setup for filtration. So it's basically a beaker, a funnel and some fluted filter paper. So you would set up your equipment for filtration. The important thing to do at the very start is to find the mass of the dry filter paper before you start. Then filter the water sample using gravity filtration, so there's no need for any sort of suction. You can just pour the water in using fluted filter paper. We use fluted filter paper as it gives more surface area, so speeds up the filtration process. And then I would leave the filter paper to dry overnight. Then the next day when you come back in, it's important to reweigh the filter paper and find the difference in the mass. So you will do the mass at the end, take away the mass at the start. So for the second part of the experiment, you want to find the total amount of dissolved solids in your sample of water, and to find dissolved solids you use evaporation. So again, you take a specific volume of the water that has been filtered. You set up your equipment for evaporation, and I have that set up down here for you in the bottom of the slide here. So you can see you've got your evaporating dish, your wire gauze, your tripod and your Bunsen burner. And basically you need to find the mass of the evaporation dish at the start, and you need to evaporate your water off, and then you need to reweigh your evaporation dish. So to finish, you will do the mass of the evaporation dish at the end minus the mass of the evaporation dish at the start, and that will leave you with just the number of dissolved solids that are present. The last thing you need to do then is you need to find the pH of the water. So basically take a sample of the water, put a pH meter in it, leave it for 10 seconds and note down the pH. So some exam questions have come up on this experiment in the past. It doesn't come up very frequently, but it's important to be prepared in case it does. A student filtered 500 centimetres cubed of water and found the mass of the filter paper after drying had increased by 0.68 grams. 100 centimetres cubed of the filtered water was then evaporated in a beaker, and the mass of the beaker increased by 0.13 grams. And they ask you to find the amount of suspended solids expressed in parts per million, and the amount of dissolved solids expressed in parts per million. So let's take a look at this question now. So for part A, we want to find what is the amount of suspended solids in the water expressed in parts per million. So if we read the question, it says that 500 centimetres cubed of water found that the mass of filter paper after drying had increased by 0.68 grams. So that means there's 0.68 grams in 500 centimetres cubed. Now you want to convert this 0.68 grams in 500 centimetres cubed into parts per million. And parts per million is also known as milligrams per litre. So the grams need to go to milligrams here, and the centimetres cubed needs to go to litres. So the first thing I'm going to do is I'm going to multiply everything by 2. So that will give me 1.36 grams per litre. So I have the litre part of my parts per million now. I need to now convert my grams to milligrams, and to do that I know that I can multiply by 1000. So if I multiply by 1000, I get 1360 milligrams per litre, and milligrams per litre is the same thing as parts per million. So my answer is 1360 parts per million. For part B, we're going to take a similar approach. The question tells us that when 100 centimetres cubed of that filtered water was evaporated, the mass of your beaker increased by 0.13 grams. So we know that there's 0.13 grams in 100 centimetres cubed. So the first thing I want to do is get that to a litre. So there's 1000 centimetres cubed in a litre. So if I multiply by 10, that gives me 1.3 grams per litre. And then to go from grams to milligrams, I know I must multiply by 1000. So that's going to give me 1300 milligrams per litre, which is the same as parts per million. So my answer for part B is 1300 parts per million. So that's it for this video. Make sure to look at the learning intentions to make sure you understand everything from the video.